Okay. After going through the difference between two squares, we'll turn around and see what this is. The difference between two cubes and sum of two cubes. So there are two parts here. Let's take part A as the difference between two cubes. Essentially, this would be tougher. However, it turns out that this is easier than the difference between two squares. How come? We'll see. If you take the difference between two cubes, this is how you get the factors. There are two factors. You close these two, the indices, right? What you see is A minus B. So that should be your first factor. Second factor can be generated from this one. How? You square this and then you square the other guy, that's B squared, then get the product, AB, write it in the middle. And in both cases, like in the difference, so in the sum, there are two factors. If the sign of the terms in the first factor changes, then in the other bracket, in the other factor, sign remain fixed. Now here, you know, plus minus means sign has changed. So here sign should be fixed, right? So we'll prove this. So we'll consider A minus B times A squared plus AB plus B squared. Now we can multiply A times this, right? A cube. A times AB, there are two A's, therefore A squared B. Then here, 1A and 2B, like 1A, there B squared. So it's AB squared. Now go for this one. B and A squared, that means A squared B, but the sign in front is negative. I just want to put these similar terms together. Then minus B times this, so sign is negative, A times B squared. Finally, these two, minus times plus, minus B times B squared, B cube. Add them up, you get A cube. This one will go away, one is plus, one is minus. These two will go away as well, leaving A cube minus B cube as the answer. Therefore, A cube minus B cube is equal to A minus B, this is equal to this. A minus B times A squared plus AB plus B squared. Right? Okay. We'll do some examples. Okay. Now, in these problems, uh, if you take these problems, the first one is quite easier. And when you go down, for example, the fifth one is, and fourth and the fifth are a little difficult. So let's take the first one. Since this is our first problem, now you would like to see it in this shape, a cube minus b cube, in this form. So you like to see it in this form. Then you can, this is how you generate the factors. Close the powers, these indices. What you see is a minus b. You write it as the first factor. Then generate the other factor using these two. You square what you have here, you square what you have here, then get the product, write it in between. And since the sign has changed here, you keep the sign remain intact. Everything is positive, like that. Now, here you can write it as, 3 times 3 times 3 is 27. So 3 cube. Close this. What you see is x minus 3. Now generate the other factor. Square this. Square this. You get 9 and get the product. Product is 3x. Since the sign has changed in the first factor, you keep the sign remain intact. You keep the sign intact without changing it. So everything should be positive there. Second, now in this case, 8x cube minus 1. How do you deal with this? Now using the rules of indices, like if you have 8x cube, let me show you. 8x cube can be taken as 2 cube x cube. So using the rules of indices, you can write it as 2x quantity cube, right? So that's what I am going to do here. I'll write this as 2x quantity cube minus, since I am allocating one step for that, I'll write cube. It's not necessary. Again, close this. What you see is 2x minus 1, right? Clear? Right. So this is 2x minus 1. What's the next factor? You square this. So 4x squared, right? You have to square both of them. 4x squared. Square 1, you get 1. Get the product of these two. Forget about the sign. Without sign, get the product. 2x times 1 is 2x. So here sign has changed. You keep the sign unchanged. Third. Not that difficult, huh? Take this one. 3x cube minus 81. 3 is a common factor. None of them is a cube and in this form. But if you pull out 3, you will end up with this. It's exactly what you had at the beginning. So this is 3 cube. You know what it is, but let me write it like that. Delete these two. What you see is x minus 3. So that's your first factor. Second factor can be generated using these two. Square this. Square 3, you get 9. Get the product, you get 3x. Since the sign of the first factor, right, sign has changed. When you move from here to here, sign gets changed. So keep the sign unchanged in the second factor. All of them should be positive. Right. Now we'll move to the fourth one. Right. This one. 8x cube y cube minus 64y cube. Now look, everything is a cube. This one is a cube, this one is a cube. This is a cube of 2xy. This is a cube of 8y, sorry, 4y. But don't rush through, just wait. If you have a common factor, you have to pull it out at first. No matter what the form of the expression you have, the rule of thumb is you pull out the common factors first. 8 is common, in numbers 8 is common, y cube is common, that leaves x cube and 8 in the bracket, x cube minus 8. That's a difference between two cubes. Look, insertion of this step is not a must. Since I am working on the board, I just want to show you how it works all the time, because I just want to give you some exposure to these things. That's why I want to insert this step, but if you want, you can straight away jump from here to here. It's okay, it's good if you can do it. But since I am working on the board, just to make sure that everybody understands this, I have to insert that step, right? Now close these two. What you see is x minus 2, look. Therefore, that's the first factor. Second factor can be generated like this, square this. Square 2, you will get 4, multiply these two. Now, everything must be positive. Five. Relatively, this is simpler than, this is simpler than the fourth one. Again, you pull out the common factors. 4 is common, y is common. Right, in numbers 4 is common, if you consider variables, y is common. That leaves x cube minus 8 in the bracket. Now this 2 cube. Now you don't have to insert this step, I don't have to insert that step, that's 2 cube. So if you close that, if you delete that 3 powers, you get like x cube and 2 cube. If you delete the powers, you get x minus 2. So using this, you can generate the other factor. You get x squared, square this, you get 4, multiply these two, you get 2x. Is the same as what you have above. Right? Okay. Now we will move to the second one. Huh? That's a sum of 2 cubes. Again, it's very similar to what we did earlier. If you have a sum, do the same thing. Close the indices, powers. You get a plus b. That's your first factor. So how do you generate the second factor? It's very similar, right? Look, you square this one, you get a squared. You square b, you get b squared. Like in the previous case, multiply these two, ab. However, you have to be fair. What do I mean by being fair? Okay, look, in this case, in one factor, sign is getting changed. In the other factor, sign remains fixed. Now look, here sign remains fixed. Therefore, in the second factor, you have to change the sign, plus, minus. So this is plus, minus, plus. That's how it goes, right? So proof. You consider that part, a plus b times a squared minus ab plus b squared. Multiply them out. So a times a squared, a cube, a times ab, it's minus a squared b. A times b squared. Now multiply everything by b. So ba squared means a squared b. It's plus these two. There are two b's, so ab squared, but it's minus. And finally, you get b cube. Add them up, you get a cube. This pair will go away. Both are the same, but one is minus, one is plus. These two will go away due to the same reason, leaving b cube there. So a cube plus b cube is equal to this a plus b times a squared minus ab plus b squared. Again, look, if you want to factor something like this, close these two. What you see is a plus b. Using this in the same fashion, you generate the other factor. Square this, get the product. Since the sign here sign remains unchanged, here you have to change the sign. You have to be fair. In one factor, signs are fixed. In the other factor, signs are changing, like that. Huh? Okay. Now we'll do some examples. These are very simple stuff, but when we move on, we'll get into difficult stuff, right? Okay, we'll take this one 8x cube plus 64 x to the power cube by cube. Right. There are 5. We'll take up the first. Okay. In this case, you can see that both are cubes. This is a cube, but this is a cube of 5. 5 times 5, 25. 25 times 5, 125. So if you delete these two, what you see is x plus 5. Generate the other factor in the same fashion like we did with the difference between two squares. Difference between two cubes. Square this, square this. Square 5, you get 25. Write the product in the middle. Write 5x in the middle. Now, it should be a fair game. Like if in a certain factor, like in this factor for sure you know that signs are fixed. So here sign should be changed, alternate, right? Sign should alternate, plus minus plus. Two. This one, 27x cube plus 8. Now, using the rules of indices, you can see that this is 3 cube. So, you can write it as 3x quantity cube. Since we are allocating one line for that, we will write this as 2 cube. So, you can see if you close this, right, what you see is 3x plus 2. So, the first factor 3x plus 2. You can generate the second factor, square this. When you square a product, you have to square each and every term. Don't write it as 3x squared. It should be 9x squared. This is 4. Now write the product. I mean, you don't write the plus sign now. Product is 6x. Here signs are fixed. So you have to alternate the sign in the second factor. Three. Both of them are cubes. However, the rule of thumb is if you have a common factor, you have to pull it out at first. So in numbers, you can pull out 8. In variables, you can pull out x cube, leaving 1 plus. You have to divide this by 8. You get 8. X cube is gone, leaving this inside the bracket. Now this is in fact a cube. So you will end up with 1 plus this 2y quantity cube. This is also 1 cube. You don't have to write that, but just to have the homogeneity, I will introduce that. I have introduced that. Now, look, close these two. What you see is 1 plus 2y. In the second factor, I mean, the second factor can be generated, you see, using this one. You first square this one. 1 squared is 1. Then square 2y. So 2 squared is 4, y squared is this. So 4y squared. Then write the product in the middle. 2y times 1 is 2y. Here the signs remain, the sign remains unchanged. Therefore, you have to change the sign here. I mean, alternate the sign. Plus, minus, plus. This is little tough. Not really, but we'll see. 4. Now, in fact, both are cubes, but no common factors. So, you have to write this as a cube. You can write this as 3 cube x cube y cube. So, inside you get 3xy, because when you raise it to its cube, you have to take the cube of each and every term, 27 x cube y cube. So, that is equal to this one. Similarly, in this side 125 is 5 cube. This can be written like this. Now, clear, close these two. Like this. What you see is 3xy plus 5z. Sometimes you call it as 5z. So, that is the first factor. Second factor can be generated using this. So, you square this. By squaring, when you square, you have to square each and every term. So, 9x squared y squared. Then square this one. You get 25z squared. Write the product in the middle. When you multiply the numbers, you get 15 variables x, y, z. Now, here the signs remain unchanged. Therefore, here you have to change the sign. I mean, alternate the sign. Five. This one. 3x cube y cube plus 24y cube. Now look, if you have a common, the rule of thumb is that if you have a common factor, you have to pull them out. 3 is common, y cube is common, you will end up with x cube plus 8. I mean, 8, you don't have to write it like that, but I just want to show you what's going on. You can straight away factor this. It's simple. Close this, you get x plus 2. I want to just re-emphasize what I am talking about. That's why I want to do it like that. X plus 2. Then write the next factor. Square this, you get x squared. Square this, you get 4. Product is 2x. Here the signs are not changing, therefore you have to alternate the sign of the other factor. Guys, so basically that's it. So in this endeavor, we need to go through difference between two squares and then difference between two cubes as well as sum of two cubes. Basically that's it. All right.